All right, and now on to our seminar today. I'm really excited to be joined by one of GFI's own grantees, Dr. Caroline Mellinger, who we're really proud to have as part of our grant program. Caroline is a researcher at the Brazilian Agricultural Research Corporation, that's Embrapa, and she has deep experience in biochemistry and the chemistry of macromolecules. Today, Caroline will be discussing all of the different opportunities for us to diversify our plant protein sources beyond just soy and peas and wheat, to look at other legumes grown in Brazil like chickpeas, beans, and lentils. So in this seminar in particular, she'll discuss her GFI research project and their focus on optimizing the production of protein concentrates and isolates from common beans, so that we're optimizing ingredients for both technological and nutritional attributes. Again, I'm super delighted to have Dr. Caroline Mellinger here with us today. And Caroline, whenever you're ready, please feel free to share your screen and begin your presentation.
Thank you, Amy. Let me share it here. Okay, I believe you already seeing it on the screen, right?
Yes, that looks great.
Okay, thank you. Well, it's my pleasure to be here. I really thank you for the invitation to be sharing some of our data and some of our opportunities for the alternative Brazilian proteins for the plant-based meats here in Brazil, right? I am, as Amy just said, I am a researcher and I work at the Brazilian Agricultural Research Corporation, known as Embrapa. And the agenda for our talk today will be, first, I will give a very quick overview of Inbrapa to show you what we have been doing and what are our missions and values. And then we'll get into the subject itself. We'll talk a little bit about the strategies on plant-based research on Brazil. And we'll also talk a little about the primary production of alternative proteins and what can be these proteins in terms of ingredients and what kind of ingredients are we investing our research on. And the third part of our talk will be the beans proteins, the specific subject of this talk. And I hope to convince you why here in Brazil, the bean proteins are our national bet in terms of alternative protein ingredients for the plant-based market. And to finish the presentation, I will show some of our data from the GFI running project that I am coordinating. Well, so first of all, Embrapa, as I have just said, stands for the Brazilian Agricultural Research Corporation, and it is the largest agricultural research and innovation organization in Latin America. Our mission is to enable research, development, and innovation solutions for the sustainability of agriculture in benefit of the Brazilian society. Embrapa was founded in 1973. It counts with over 9,000 employees, from which over 2,000 are researchers. We are spread all over the country into 46 research units. So every little dot here is a research unit. And we have our headquarters here in the Federal District in Brasilia. Besides working all over the country, we also have international platform cooperation, either for the scientific or technical cooperation. So here in Brazil, our research centers, they are divided into thematic centers. For example, I come here from, I belong to Embrapa agro-industry here in Rio de Janeiro. We do also have product centers, like for example, here in the south of the country, we have Embrapa wheat, Embrapa soybean, Embrapa grape and wine, and some other units all over the country, normally close to the agricultural production of these products. We also have research units devoted to study the agroforestry or eco-regional themes. For example, here in the north of the country, we do have Inbrapa Western and Eastern Amazon. We do also have some special service, which are units that do not research, but they are based mainly on business, and our headquarters here, as I have just said. And in terms of international cooperation network, we do have some offices set up in the US, Europe, and Asia to work on scientific cooperation with different groups on the north of the world. And we do also have south-to-south cooperation in terms of technical cooperation with some countries from South America and from Africa. Well, have all that being said, let's get to the topic of our conversation itself. So the first thing that I want to talk is about the strategies on the plant-based research. So when we think of the plant-based market, we have to take a broader look that goes from the farm to the fork. And to be able to produce food and beverage for the plant-based market, we need to be able to produce ingredients that will be used to formulate these products. And to be able to produce ingredients, we have to be able to supply the industry with the raw materials. So we do have three main streams of research to be able to develop innovation and products for the plant-based market, right? And we cannot forget that more and more, the consumer is a key player in all that is being developed for this market. And where has Embrapa been acting? So as I have just said, we have many different units, research units, and these units, they are working on different streams. So we do have some units of Embrapa that are working on breeding programs for us to be able to produce more and better the raw materials. We also have some units, such as the unit where I come from, that are working on the technological aspects to produce ingredients and to formulate products. And for today, we are not talking about the product formulation, but we do have some information in case you are curious or you want to know more about what we have been doing. We do have a homepage written in English, so you can have deeper information on that. And we will focus our talk on the raw material possibilities and ingredient development that we face here in Brazil as opportunities for the plant-based market. Well, let's start with the raw material and the primary production. Well, we already know that we do need to diversify our sources for the protein obtainment for the plant-based market. Not only for the plant-based market, but also to feed the world in terms of protein supply, right? We already know the animal protein won't be enough. And if we do stick to one or two or three sources of plant protein, they also won't be enough, right? They are already not enough. So diversifying the sources and looking for different sources is mandatory for us to supply the plant-based market and also the protein supply for the world. Here in Brazil, we do have many different possibilities. Brazil helps to feed 800 million people over 200 countries. We are the third largest food producer of the world. So we do have many possibilities of producing proteins from different sources. And from many sources that we are able to do that, we do have the legumes and pulse as a main possibility. And we also, just like every other country, can also produce proteins from cereals, from mushrooms, from algae, from roots, right? So we can, in Brazil, with our primary production, we can go deeper and deeper on the protein production. For today, I decided to talk about pulses and legumes production, because this is what we have been working for the GFI's project, and this is what Inbrapa has been deeply involved in developing. Well, so why legumes are an attractive agricultural chain for the protein production in Brazil? Legumes, they are abundant. They do have a worldwide abundant production, and they are very abundant here in Brazil as well. They are a natural source of protein, starch, fiber, and other micronutrients. And as we are looking for protein and protein ingredients, legumes, they do have higher amounts of proteins naturally on their constitution when compared to many other types of vegetables. And these proteins, they are mainly globulins and albumins, and they are storage proteins. So the way we can address processes and the way we can get those proteins as being storage proteins makes our job easier. Well, and who are representatives of legumes that are worthwhile talking? We do have soybeans and peas. Well, I will not talk much about soybeans and peas because they are very well known and used proteins as ingredients for the plant-based market. Just for you to have an idea, Brazil is the second largest producer of soybeans, sometimes the first one. It kind of goes with the United States, right? So depends on the year, one is the first, the other one is the second, and vice versa. But we do produce over 114,000 million of soybeans during a year, right? So I will not talk about the soybean production. I'm sorry, I'm kind of distracted because I don't know if the noise is kind of bothering you. Can you hear me well? There is the airplane passing by. There is the neighbor doing some work on the house. Are you hearing me well? I'm sorry.
Yeah, we can hear you beautifully.
Yes? Okay, okay. Thank you, Amy. I can, oh my God, sorry about that.
You're all good. Sounds like there's quite a vibrant city life right in front of you.
Yes, yes. Thank you, Amy. Well, so we do produce soybean, and we are a large producer of soybeans. And soybean is the mother protein for the plant-based market, right? It's on the market over 40 years. We do have plenty of ingredients. And here in Brazil, we do produce lots of flour concentrates and isolates that come from soybeans, right? In terms of peas, I will not talk much about peas as well. Here in Brazil, we have an incipient pea production, and we do have to import all of our ingredients for the plant-based food and beverage, right? So we do not produce peas very much, but Embrapa Vegetables is a research unit of Embrapa is investing on breeding programs for us to produce more and better peas in Brazil. And as new representatives or alternative agricultural chains that we are already producing, that we are already having an increasement in production, we have beans, chickpeas, and lentils. So I'll talk very briefly about chickpeas and lentils, and we will concentrate this talk on the beans production and the beans proteins. Okay, so we all know we have new demands and opportunities for the protein production in Brazil and on the world. And besides soybean and peas, we need to have an increase of over 20% of pulse production all around the world for us to be able to supply the world's demand. In Brazil, these opportunities, they go together for a national plan of bean and pulse chain development that was launched in 2018 from our Ministry of Agriculture, Livestock and Food Supply, together with Inbrapa and some other associations. So in 2018, this national plan was launched, and the main goal of this national plan is to increase the grain production in different pulses chain, including the bean chain. And together with this increase, it's also included on the goals of the plan, the enhancement of the processing and industrialization of the grains. So we can also not only produce better and produce more the grains, but also aggregate value to the grains that we are producing here in Brazil. So that copes, this national plan copes and goes together with the demand that is coming all around the world, not only here in Brazil. And what can we tell about beans in terms of national production? Well, Brazil is the third, sometimes the fourth largest producer of beans in the world. We do produce every year around 3 million tons of different kinds of beans. And the national plan that I have just said is willing to have an increase in the post-production together with the bean production by 20% up to 2018. And this increase will be up to the 3 million that we are already producing now. And what types of beans do we produce in Brazil? So we do produce the more than 14 types of beans, and they are all called common beans. They come from the Phaseolus genera, and they are divided into different varieties. And from these varieties, we do have pinto bean being the main bean produced in Brazil, followed by the cowpea and the black beans. So we have decided when we chose to work with beans for protein production, of course, we decided to to start our research on common beans, and we had to choose one of the bean varieties. And because of the production of the pinto beans, we have decided to devote our research on this variety. And this is how it looks like. Well, we will be talking about beans, but I just wanted to show a little bit of other opportunities that can come right after the beans in terms of agricultural chains for the protein production in Brazil. So the chickpeas is also a very interesting agricultural chain. Chickpeas are the second largest legume grown and consumed in the world, followed only by soybeans, right? Brazil is not a very large producer. India is the largest one, but that's we do have a very interesting story to share with you. In 2015, Inbrapa Vegetables launched a variety of chickpeas called Aleppo. And this variety was very well adapted in our conditions of climate and soil. And from 2015 on, up to the moment, we have become self-sufficient in producing the chickpeas that is consumed in Brazil. And we have already started to have an excess of production, and we are starting to export that to Asia. So we do produce around 8,000 tons per year. And after the launch of the Aleppo variety, our planted area has grown over 1,000%. So we are still, and Embrapa Vegetables is still working on breeding programs, and we do have good expectations that will be a bigger producer of chickpeas on the following years. So let's keep our eye on chickpeas chain as well. And the lentils, well, our cultivation is still very, very incipient. We basically import almost all the lentils that we consume, right? And we do have some breeding programs in progress. Embrapa Vegetables is also in charge of that. And after the chickpeas, we plan to become a major producer and exporter of lentils as well. So for us, in terms of agricultural chains, taking a look into legumes and pulses, we would say beans, chickpeas, and lentils are great opportunities for us to produce proteins from them, right? So having a first look on the raw material, let's go for the next talk, which would be the ingredients for the plant-based food, right? What are we doing in terms of ingredients, and what are our project's aims in terms of producing protein ingredients for the plant-based market? Well, we all know ingredients, they play a key role in the plant-based food because they are responsible all together for the product's formulation. And from the ingredients, we can offer the consumer the desired sensory experience. And when we do think of ingredients, we have many different types of ingredients, right? It goes from proteins, food coloring, dietary fiber, flavoring, fats and oils, and many different ones, right? Embrapa do have some initiatives on different ingredients for this market, but today I'll keep my talk on the proteins. So when we choose which protein we are going to use to formulate our product, we do have some expectation that comes from the protein as an ingredient, right? And we do find ingredients from different sources and presented in different forms. So we do have flours, concentrates, isolates, textured, the old generation textured ingredients, the new generation textured ingredients, right? But we do have different sources and different presentations in terms of protein ingredients. And what do we want from them? Well, we do want them to perform technologically in the product, to help building the product together, right? So when we think of producing a plant protein for the plant-based market, we have to monitor all the technological properties of them to see if they will cope with expectation when the product is being formulated. And this is quite old, right? But now we do have new expectations and new demands. But more and more recently and deeper, consumers are willing to have ingredients and of course products with enhanced nutritional, health, and sustainable aspects, right? So we have to produce the ingredients, we have to check on their technological properties, but we do also have to monitor these aspects to cope with the consumer's expectations. So it's not so easy when we think of producing a protein from a vegetable source, right? And when we think here in Brazil, when we started talking and thinking, what can we do and what will be our choice in terms of agricultural chain, in terms of process, how are we at Inbrapa and Brazil, how are we starting our studies? So the first thing that we did was to think of the primary production. For us, it wouldn't be worth it to start working with lentil because we wouldn't have enough supply of lentil production to offer to the market, right? Soybean is already done. It's on the market. We don't want that. So we had to choose from beans, from chickpeas, from any other source that we could imagine at that time, and how could we decide it based on our primary production, but also based on the composition, because that is also important when we think afterwards on the technological routes that we are going to use and the yields we are going to recover after our production, right? So also was part of our decision to take a look at the legume composition. And we took this data here from grains that were cultivated in Brazil, because we know we have different composition when we talk of the production in different countries. So we got different literature and data from pulses that are cultivated here in Brazil, from our own varieties, right? And compared their composition, right? The crude dry grain composition. And taking out of the comparison the soybean, which we know they have a higher amount of protein as well as a higher amount of lipid, right? So take soybean out of the comparison and compare pea, pinto bean, chickpea, and lentils. We decided that we were free to choose because in terms of protein, they were very similar in terms of their protein content. that ranges from 20 to 25%, sometimes more, sometimes less, depending on the cultivar, right? They had, except for the chickpea, they have low and similar lipid content, but still talking on chickpea much lower than when comparing with soybean. Similar carbohydrate content, mainly starch, and similar dietary fiber content, right? So besides beans being the second legume produced in Brazil, we also taking a look at the legume and pulse composition. We thought bean was a good opportunity for us to start working with. Well, a third discussion that we have to, to define, right, we are going for beans and that's it, was to take a look at the plant-based market. Why? Because here in Brazil, and taking a look first looking for the Brazilian consumer, and it can be, of course, be extended for abroad, but taking a deeper look in our market, we here in Brazil, we consume our daily meal is mainly composed of rice and beans. And then we normally have an animal protein source, and then other legumes and salads and other sources of vegetables. But rice and beans, we say it's the Brazilian food. And we were kind of afraid because rice and beans are very well known and communicated to the consumer, and they could be facing that consuming rice and beans is how beans should be consumed. And we were afraid if they would accept other kinds of ingredients and if they would accept beans being part of plant-based products, right? So we did deeper studies on that, and we also took a look at some market trend companies, from some studies from Brazil and some studies from abroad. And what we are seeing is that the bean protein production is increasing, and it's estimated to increasing even more up to 2026. When we look to the international market, we look mainly at fava beans, but also at mung beans, and we don't see data from common beans, right? But here in Brazil, our main productive system is for common beans, right? But taking advantage of this growth in international market, we also thought that beans will also arrive in Brazil as pea did. And we are already seeing that. And the consumer is accepting to have different protein sources on their products, right? So bean became a great opportunity, not only because it's abundantly produced in Brazil, not only because its composition favors the production of protein, of plant protein, but also because the market is indicating that we are growing on the demand and on the production of different beans proteins, right? And still, if we look the international market, as I told, we do have fava bean and mung bean, the main varieties that are used to produce concentrates and isolates and textured proteins, right? If we check, they come from different species, different varieties, and they are very different than the common beans that we do have in here, right? Not very, very different in terms of composition and in terms of ultra wall structure. They're basically the same, but they are different varieties, right? And our idea then, when we really decided to start to work with bean proteins, is that we do have an empty plate in here. We do not have in Brazil or around the world beans, common beans being used to produce plant proteins for the plant-based market. So our aim is to start to filling the plate, right? And helping the production of the alternative proteins for this market. Well, what do we have running at the moment here in terms of ingredients production? We do have some running projects, and the main aim of these projects is to produce concentrates and or isolates coming from beans, chickpeas, and lentils. And we do have an Inbrapa funded project and a GFI funded project, right? And I'll talk a little bit about the initial results we are having on this project in here. Here, me and my colleagues were coordinating this theme inside Inbrapa food agro-industry. Well, so as I have just said, our main aim is to produce the protein concentrate and isolate coming from different pulses. And let's focus on bean protein concentrate and isolate. And we have not started working on the isolate production. So today I'll focus on the bean protein concentrate. And to have all this production coped, we need to go step by step on some specific aims for the project, right? And what I will show you is are some data for the lab scale production of the bean protein concentrate and what we have done in terms of pilot plant scale production for the bean protein concentrate. So these data we have already worked and we already have significant results to share with you. We are at this moment working on the technological properties of this concentrate, and after that we'll have to work with the nutritional properties and on the product application of the concentrates and isolates that we will produce. And we did not forget to take a look at the starch and dietary fibers that comes as side streams of the protein production. Well, here, what have we done in terms of lab production for our bean protein concentrate? So we do have the dry grain. After milling the grain, we have a whole flour, right? And here we had to take a choice. What is the route that we are going to choose? Another choice, right? So after choosing the bean, now how are we producing the concentrate, the protein concentrate? How are we producing? Are we going through dry fractionation? Are we using alkaline extraction followed by acid precipitation? Are we using saline extraction? What are we doing? And we do have, as I have already said, we do have a very large production of soybean ingredients. We do produce concentrates and isolates for the animal, for feed and for food, right? And we thought that could be an alternative using the facilities that we already have here in Brazil and the companies that are already settled here in Brazil. We thought that using the classic way for obtaining the concentrate would favor the beginning of the production of the concentrates here in Brazil. So we thought it would be faster and would be helpful for our internal market, right? So what we did after having the flour, we did the alkaline extraction. After the alkaline extraction, we did an acid precipitation from the isoelectric point of the proteins. After that, we had our concentrate. This concentrate went through a washing step. And after the washing step, it was dried in a lab scale spray dryer. And then we had the powder. So this was the route that we have chosen in terms of processing, right? And I will show you some of the data that we have step by step on this processing route. So the first one was the milling process. So no big deal on that, right? We have used the hammer mill and we decided to use the whole flour. So the bean was not the whole, right? We have used the whole flour. And we have used beans from different suppliers exactly for us to have an idea of the protein content range from these different suppliers. And we have worked up to the moment with beans since 14% of total protein up to 19.7% of total protein. And the process we have done using these different raw materials, they were very consistent in terms of protein recovery, even from the lower or the higher sample that we have tested. Well, the second step was the alkaline extraction, and we have used sodium hydroxide for that. Each experiment that we did, was with 100 grams of bean flour, and every parameter that we have tested, we did in 3 replicates, right? And what were the variable parameters for the alkaline extraction that we have tested? We have tested the pH to check on the optimized pH for the alkaline extraction, the time of extraction, and the soluble water ratio. And we have monitored the results. Our dependent variable of the process was the measurement of the soluble protein content. And what we do have here? Well, these 3 graphs show the pH result that we have found, the time of reaction, and the flour water ratio. So for the pH, we went from the pH 8 to the pH 10, and we could find an optimized range of pH with a recovery of 36% of soluble protein. So that was pretty good. In terms of time of reaction, we have tried from 10 minutes of reaction up to 110 minutes of reaction. And we have seen that over 30 minutes of reaction, the recovery of protein remains stable. And that recovery from 30 minutes on was around 35% of soluble protein. And the third parameter that we have checked, the flour water ratio, we have tested ratios from 1 to 4 to 1 to 16. And we have found our optimized point here at 1.8 with a recovery of 38% of soluble protein. So these experiments, they were independent, and it was very nice that the recovery of the proteins remained similar among them. Well, the next step was the acid precipitation. We have used hydrochloride acid, and we have tested some variable parameters as well. We have tested the pH, the time of reaction in terms like the time of precipitation, if all the proteins would precipitate at once, or if we needed to force some more and leave the reaction occurring for a longer time. And we have observed that we still had some of the protein on the supernatant, as we can see it here. And we would like to force a little bit more this precipitation. So we have tried an overnight cooling. I know this in terms of processing of industrial processes is not much worth, but in terms of scientific, the point of view and checking on the tertiary structure of the proteins and how do they remain stable or not would give us some precious information. So we have tried that as well. And here our dependent variables. So we have monitored all of our experiments by using the total protein content. And here we have the data to share with you. So here we have the pH for the acidic precipitation. So we went from a range from 4 to 6. And we have found, I know it seems like it keeps on increasing, which is pretty weird, right? Because globulins and albumins, they should precipitate more around here. So it was kind of surprising for us. And I know it seems like it's still going up, but it's not. And at pH 6, we didn't have good results. We didn't have a good protein yield. So we thought that the pH 5.5 would be a good option for our processing. In terms of time of reaction, so as expected, the protein gets to its isoelectric point, it precipitates right away, and that's it. So we don't need a longer time of reaction, right? And in terms of the cooling process, so we have left a sample of our concentrate in the fridge. So the temperature was about 7 Celsius degrees, right, over 12 hours. And we didn't have any increase in terms of protein percent. So cooling wouldn't help anyways. And the recovery of the proteins in here, they were also very consistent, and they ranged from 72 to 75%. Our best recovery, right? Well, so after having the alkaline extraction, the acid precipitation, we went for the washing. This step was very simple as well. We resuspended the the concentrate and left it under agitation for 10 minutes and send it to the drying process, right? So we have used first for the lab production this lab scale spray dryer, and this is the powder that we ended up with, right? With a good recovery as well. So after all, we did have a protein content for our bean protein concentrate of about 75% protein, which is very, very good. Taking into account that we started with the grain having from 14 to 19% of protein, so that's pretty good. And we still have an alkaline residue that still has 6% of protein. So we still are studying if we're going to try some additional processing step for us to be able to take a little bit more of the protein that's still left on the residue. Well, after doing that for the lab scale, we did a very first enhancement of the scale of 10 times. So from 100 grams per experiment, we went to a kilogram of bean flour per experiment, right? And we're checked, and then we did check on all these parameters that we checked for the lab scale. We also reproduced it for the pilot plant scale, for the initial pilot plant scale, right? So here I do have some pictures of the processing. It's all the same, right? So we do the milling, we do the alkaline extraction, now with all the parameters already set. Then we do the acid precipitation. From these first steps, we do have the residue as a side stream and the supernatant of the precipitation step. We are working on these side streams as well, right? But we are not talking about them today, but it's important to be aware and to know that we are working on that. Okay, so here after we have the acid precipitation, we send the rest suspended material to a pilot plant spray dryer. And here we have our powder bean protein concentrate, and the amount of protein remains pretty much the same in all replicates that we have then. Well, so as I have already told you when I was talking about the project aims, right? We did already find the optimized parameters to produce our bean protein concentrate, and we are already working on the next steps. And I hope to be able to share with you on the next talk some of our technological and nutritional properties of our protein. And our final expectation is to be able to offer complete scientific data on the production and characterization of pinto bean protein concentrate in order to support the Brazilian supply of ingredients for the plant-based market. And said all of that in name of our team, I thank you very much. And as I say in Portuguese, obrigado.
Thank you so much, Dr. Mellinger, for that fantastic presentation. I just loved how organized of a communicator you are. That was such an informative presentation, and I'm excited to look back on your slide deck. For those of you who haven't already, feel free to drop your questions for Dr. Mellinger in the Q&A section. I see a few different questions here already. Feel free to continue adding questions you have. The very first question that I'd like to ask you is from Ite. Do you have any information about the techno-economics of producing such protein concentrates? Specifically, they're curious about the cost of producing 1 ton of protein concentrate in beans compared to soybean, for example.
We do not have this data, right? And it's we can produce some predictive data, right? Because it will to have this kind of data, we needed to know the size of the producer, the capacity, right? The number of works. So when we are able to do an industrial scaling up together with a partner, or together with partners, then I think we can have more accurate data on that. We have not worked so far, right? And we also have to take into consideration the aggregated value, right? From the soybean or from the alternative bean proteins, beans or any other source of protein.
Yeah, that makes a lot of sense that we can project out at scale, but the entire supply chain has to scale. So it's kind of an empirical question. Awesome. My next question here is from John. Since you mentioned that your final pinto bean protein concentrate was 75% protein, there are a lot of questions here from attendees curious about what the other compounds are that constitute the remaining 25% of the bean protein concentrate.
Okay, mainly starch and dietary fiber, right? So we, not for the GFI project, but we are also not at this moment, right? It's not any specific goal for the GFI project, but we are keeping our eye on that, right? What's coming and how can we take a good advantage of that, right?
That makes a lot of sense. So obviously, one of the questions our community is the most excited about getting answers to is about the applications of these studies to plant-based meat. So we're kind of curious to hear from you whether you have any preliminary data about how these protein concentrates and isolates might perform in sensory studies in a plant-based meat product.
Yes, we intend to do that and we will do that, but we have not started so far. We want to have it fully characterized first, at least on the technological properties, and then we'll go for the application step. But yes, we'll do that for sure.
Yeah, I really appreciated you mapping out your research roadmap. It was very cool to see that clearly laid out, especially the consideration of side streams, which leads to my next question. Yeah.
I apologize for my English. Sometimes I think I'm not quite clear, you know.
No, you are.
Okay.
I was gushing actually about how wonderful of a communicator you are to all of my colleagues privately in the chat while you were presenting. I was like, I've got to take tips on how to be a better presenter here. I thought you were phenomenal. And I also very rarely see researchers who lay out the research aims so clearly so that we know, what step comes immediately after the steps that you're sharing with us. So that was very cool to see.
Thank you.
We have questions here about the side streams and their intended uses. So can you reflect to us on potential uses related to the alternative protein industry for those side streams?
Yeah, well, that is a tough one, but not only for us and for our projects, I mean, all around the world, right? How are we making a good use of it? We really have to think of that together, right? Because the residues actually, they are the main mass, right? Main yield of the whole grain. So we take off 10, 15, 17, 20% at most. And what can we do with the other 85%, right? So that's a big, big challenge. What we plan to do is to check on the technological properties of the whole residue together. So maybe it can be an alternative to apply into like meat products, for example, and fractionating them into starch and dietary fibers and separate, because then from the starch you can have other kinds of applications, right? Specific applications. I don't know if we are going to be able to get all that really to the deep point in terms of research, but we have to keep on thinking of that, right? The P starch and the P fiber has already been facing some trouble on that, and we'll have the same thing going for other sources of proteins for sure.
Yeah, it makes sense that as we look towards this next kind of phase of the plant-based meat industry, valorizing side streams is going to be one big question that we all have to answer,
Yeah,
especially with an eye towards sustainability. So it sounds like there will be many extensions on your existing research project for
yeah,
other
sure,
researchers to take on in addition to your lab.
for
Um,
sure.
Awesome. Well, there's a question here from Priera on GFI's team. It looks like you didn't have to use a defatting step to enrich the pinto bean protein. Is defatting usually used in the industrial protection for soybean protein enrichment? And would you say that this is another benefit of moving to legumes with a lower lipid content?
Yes, well, it is when we produce proteins from soybeans, for sure you have to defat it, right? So you have like 20% of oils, fats and oils. And here in Brazil, I know in the US and in many other countries, you don't have your main oil do not come from soybeans. But here in Brazil, our main cooking oil, the common oil, they do come from soybeans, right? We don't have that much of canola or corn oil. So our main cooking oil, the daily cooking oil, they do come from soybeans. So we already have the leftover from the oil production, right? So the meal, let's say. And then, yes, it's from the meal that the proteins are obtained, right? From the bean, we didn't have to the fat, and that's very good because it lasts one step in terms of the root, right? The processing route, because the lipid content is very low. And we do believe that for the other pulses, with the exception for the chickpeas, which is like a quotation mark. I don't know how it's going to be for the chickpeas, but for the other ones, I really believe we don't have to defat it.
Awesome, thank you. Yeah, that does sound like a really great optimization of the process, removing one step.
Yes.
Um, do you think that there are ways to improve the protein yield over what you've showed here? Like we saw a protein yield of 75%, which is pretty astounding. But could you imagine additional processing steps or other kinds of enzymatic processes that might further improve that yield?
Yeah, well, the literature brings many different possibilities, right? We could do addition of enzymes. We could use like ultrasound now is so up, right? We have many researches by using ultrasound. But I'll give you my personal opinion. I wouldn't use thinking of see, we want these ingredients to reach the industrial level as soon as possible, right? So I wouldn't add a step that what we have in terms of industrial facilities is not ready to accept. You see? So I really do believe that ultrasound and enzymes would do good to remove part of the 6% protein that remains on the residue, right? But I wouldn't do that at this moment, thinking that we want to get to the industrial level as soon as possible. Uh, Although like simple process can also be tested. Um, Maybe using a little bit of temperature in the alkaline step could do some good in terms of uh, disconstituting, if the word existed, like uh, breaking up the cell wall ultrastructure and maybe releasing a little more of protein. So temperature could do some good. Uh, Cooking the bean, toasting the bean. So I don't know. I would think of something very simple and low in terms of cost. If we do think that at a certain point we need to remove more than we are already removing. So I would go on that kind of way.
Thank you. That's super helpful. There's a question here from Indra about a project they're carrying out on dry fractionation of pulses in India. So they're currently in the early stages of their research project, trying to select the raw materials. And they're asking if you can speak to the criteria that you suggest keeping in mind while they're selecting raw materials for their project.
Well, first of all, you have to see what you produce, right? You need to, I'll give my answer, but then please help me to see if I if I gave the right answer, okay? If I cope with what he is willing to hear. So first of all, you have to produce whatever you want to fractionate or whatever protein you want to produce, right? You need to have a primary production of that. So you can ensure the supply of the raw material for the ingredient production. That's the first thing. So do not go for researches for things that you are not good producers or that you have not well established and organized agricultural chains. That's the first thing, right? After that selection, if he is going for dry fractionation, I think a good thing to do is to select plants that are naturally richer in protein. So like pulses would be a good alternative, right? Because then I think the yield of protein that is going to be fractionated is going to be high, right? So let's say, I don't know, I'm just trying here to think, to brainstorm myself, right? So first, what you produce. Second, go for what's naturally abundant in terms of protein. Then you can take a look how this protein is in terms of constitution. So like in that kind of material, is this storage protein, constitutive protein, where these proteins are in terms of the structure of the raw material, for you to see how easy or hard it will be to fractionate them into the classification, right? And then the composition and the market as well, right? No, many things. So the composition and the market, to see if your consumer is ready to accept whatever you are trying to produce. I don't know if that's what you wanted to hear. Was it?
Yeah, that's incredibly helpful. And Indra, if you had follow-on questions, feel free to add them back into the Q&A, but I think you laid out the different considerations really clearly. That's very valuable. There's another question here about whether you've tried other kinds of processes beyond alkaline and acid precipitation. So they're hoping you can kind of reflect on your decision to design the study around these two processing methods.
We did not. We could do, you see, we have to set some limits because science is endless, right? And we really need to be careful on that, because then you bring up one variable to analyze, one variable parameter. But then from that, you can open up another 5. And then from another one, you open up another 5. And then from another one, you open up another 5. So you never finish things. You keep on opening. And at the end, you will have so many data to analyze that you're like, why did they do all of that? You know, because science is endless. So sometimes our team, we have our discussions, and sometimes we brainstorm what is going to be next step. And when we look to ourselves, we are opening up too much, right? And we're like, no, let's get it closed again. So because it's natural from who works with science to do that. So we decided from the beginning, we had to take a first choice. Is it going to be dry fractionation? Is it going to be wet routes of processing? Is it going to be alkaline, aqueous, or saline? Okay, it's going to be alkaline. And then we left all the other possibilities. We didn't want to keep on opening them. Okay.
Yeah, it makes a lot of sense. I feel like scope creep rather is very real for research projects.
It's very real. Yes.
Infinite, boundlessness in front of you.
Yes.
But can you share your rationale, like why alkaline as opposed to aqueous?
Because we thought, well, it's the classical route, right? It gives you a good yield. It is the classical one. So it's already being done that way. So why not using what's being done and checking how it's going to get with the different protein source? I know we are not innovating very much in terms of processing, but that was not our aim. You see, sometimes I've heard once a colleague of mine say, but what's new about doing alkaline extraction of protein? Like nothing. I said, yes, exactly nothing. But that's what we want. We want what's already being done, tested with another kind of a raw material, and we want it to work. And that's how we face it. It could be faster in terms of development, right? So that's it.
Absolutely. Yeah, that makes all the sense in the world. Thank you for illuminating your decision pathways.
You're very welcome.
Yeah, you spoke to this a bit earlier on in the seminar when you were laying the groundwork for, why look beyond soy at all? And I'm wondering if you can reiterate some of those points. An attendee has asked, soy protein has greater than 2 times the amount of protein content in these legumes. So why even bother with other sources like beans that have so much less protein content to begin with?
She's totally right. I'm really pro soybean, right? If you talk to people that work on product development, they will all agree that soybean protein is fantastic. And in fact, it is in terms of technological properties, in terms of nutritional properties. Soybean is fantastic. Soybean protein is fantastic, right? And I do not think we have to replace soybean protein. What we do need is to add it up. So we do have soybean protein, but only the soybean protein will not be able to afford all the protein we need. So the diversification of source is mandatory. So I do not want to take soy out to replace it with other protein sources. The idea is to have different sources to cope with the demand.
Absolutely. Thank you. And also, when we take biodiversity into consideration and the need for, like you said, utilizing native regional crops and things like that, I think there will be lots of benefits from an environmental perspective to pursuing diversification of protein sources. Um, Awesome. Folks, we have just 23 minutes left in the session. Please continue to ask questions to Dr. Mellinger here in the Q&A section. We have a few more to work through here. And this next one is whether you have tested any functional properties of these isolate proteins from beans, like emulsification or gelling. I think you spoke to this being in your subsequent research plans, but lots of
Yes,
questions
yes.
here about
We
this.
are, yes, sure, thank you. We are doing that now at this moment, right? We are finishing part of the properties. So we are testing emulsification capacity and stability of emulsion, foam formation and stability of foam, water solubility, water holding capacity, oil holding capacity, gelation or gel formation. Let me pick if I forgot some of them. Give me a second, but we are testing all the important ones. Let me see here. In one of the slides, they were all together. Yep, I think that's it. Yep. These are the ones.
Do you have preliminary data on how those functional properties compare to soy?
I was not prepared to that one. I do know, but I don't know right now because I didn't check that one before
No
coming in
worries.
here. But what I can tell you, I will not compromise myself giving you a wrong information. Some of the properties were pretty even, and we did not only compare to soybean protein. We compared to soybean protein, soybean concentrate and isolate, pea protein and pea protein. Gosh, pea concentrate and pea isolate, and also fava bean, because we wanted to have a range of ingredients that we do have available here in Brazil to compare our ingredient with, right? So we did test concentrates and isolates of soybean, concentrates and isolates of pea, and the fava bean protein, right? And some of the properties, they were pretty even among all of them. The isolates, in general, they do have much better properties, right? And that's okay. We expect that to happen. And some of the properties, they were uneven, but I will not tell you anything further than that because I may be telling you something wrong.
No worries. That's very helpful. Perhaps the attendees who are curious can follow up with you to ask after the seminar. Awesome. We have a couple questions here. One is about how beans, for some swaths of the population, tend to have side effects when you're eating them, such as gastrointestinal discomfort. So do you know how likely it is to eliminate these kinds of experiential side effects while making the concentrate protein powder?
Yes, well, we are testing that, the oligosaccharides that promote all these side effects, right? We are monitoring and measuring them along all the process, right? And well, I'll tell you something that I do believe it's going to happen, but I have not tried at all, okay? Because we still are not monitoring that. We are on the production parameters testing, right? So we did not check on the oligosaccharides and how they are migrating. But I do believe they will not be, or a greater part of them will not be on the concentrate powder because of the alkaline extraction followed by the precipitation, the acid precipitation, right? So I do not believe that unless these oligosaccharides are interacting, they're not covalently bound to the protein because that doesn't happen, but they might be interacting with the protein. So some of them can migrate together, but I do believe most of them might be separated along the process, but we did not check on that, okay? It's just a speculation.
Sounds good. Thank you. There are a few questions here about physical infrastructure. So what is, the use of hammer mills for your process? This attendee is asking whether it was a single or multiple grinding stage process and whether you're kind of satisfied with this means of milling.
Yes, we did 2 millings in sequence, right? To be able to have like a finer flour. We decided to go for the whole flour. I know there are lots of studies and lots of people that works on the fractionation to have the particle size into a more homogeneous space, right? But we didn't want to do that because we do not want to waste part of our protein, right? So we decided to go for the whole flour, but we did use 2 milling process in sequence to have a finer flour. That was it.
Understood. Thank you. And then also in terms of the other physical infrastructure that you all have available at Embrapa, looks like Tiago is asking what kinds of physical infrastructure, like grinding, concentration, isolation, what kinds of factors can be tested? I'm not sure I know exactly what that question means. If you do, feel free to go for it. But Tiago, if you can just drop in a clarification, that would be super helpful.
Okay. Well, in terms of infrastructure for the lab scale production, it's pretty simple, huh? We do that on beakers, right? Under agitation. So it's pretty simple in terms of infrastructure when we consider lab scale. The drying process is a little bit more fancy in terms of process because then you need the spray dryer. But if you do not have the spray dryer and you want to start working with that, you can use an oven. Is that how we say that in English? A, uh, a dryer, an oven dryer, right? An oven dryer. But then the technological properties of your powder will be much different than the spray dried one. But that's okay if you want to check on protein amount, on recovery, on other things, you can do that, right? For instance, just to start, right? So it's pretty simple. I guess that's it. And then if you want to add new steps, look, you can work with a membrane fractionation, for example, which is fancier, right? Then you'll have to need that kind of infrastructure, right? So it depends on how fancier you want to get on your processing.
That makes sense. And so for if someone is curious to know, whether there's a comprehensive list of the research infrastructure you guys have available, the types of equipment you have available at Inbrapa, is that something that's available on your website?
Yes. Let me get the link in here and maybe we can share on the chat.
Yeah.
What do you think?
Yeah, that sounds great.
Because then, yes, maybe sometimes not everyone could take note of it. So let me just find here. And then we can share. And then in there, right? In there, it's a website. Let me see. Can I think I do can. I can, okay.
Yep, I see
See
that.
there, Amy, and then probably you'll share with everyone, right? From the
Perfect.
audience.
Yes, I've just shared that with everyone, so
Okay,
you can
thank you.
see through
So
their
in
website a
that,
list of,
yes,
yeah.
on that website, it's from the whole Inbrapa, right? So you can see many different, all the 46 research units. In case you want to get to us, then you have to look, you can Google it, Inbrapa Food Agro-Industry or Inbrapa Food Technology. Then you'll get to our, straight through to our web page, yes, to our
Awesome.
homepage, whatever. Yeah.
Thank you. There's a question here from John. Is there any residual bean taste in the protein concentrates? Did you try it?
We did. We did. A residual taste it does have, but it's not bad. It's not bad at all.
Yeah, thank you. There's a question here from Indra. Were you able to separate three different fractions, the protein, starch, and dietary fibers? Because from what they see, most of the scientific literature is only, able to make the protein and starch fractions.
We have just really started to work on that, but we aim to fractionate the starch. And then well, if we think of macronutrients that compose the grain, right? We do have the main three. We don't have lipids, so we do have starch, dietary fibers, and protein. So if you take out the protein and then you fractionate the starch, the leftover is mainly the dietary fiber. So that's the approach we are thinking of using.
Yeah.
And mainly the insoluble dietary fiber, right?
That makes sense. Thank you. All right, we have just a few minutes left here. Taking much of the research that you detailed to us today covers the ingredient optimization. Once you've already sourced your raw materials, the ingredient fractionation and optimization. And so this question is about the earlier stages of agricultural production and whether you see an opportunity to improve agricultural methods such that we're actually getting better protein ratios in the raw material to begin with.
This is really starting to grow all over the world, right? It was not something really commonly done like 7, 8, 10 years ago. I think it's getting there, right? Normally when the companies, private or governmental companies, when they think of breeding process, the agronomist, this is agronomic way of looking at the breeding, right? What do they want? What do agronomists want when they go for breeding programs? They want better productivity. They want better resistance to pathogens, right? So they want the plant to produce better and more, right? But now it's pretty new, and I think it will grow and grow, doing the breeding programs to enhance some nutritional aspect that we want, right? So you can enhance the protein content, you can enhance the fiber if that's the case. So I think that's something that will grow in terms of science from couple of years ago on, right?
Thank you so much. Here's a question from Guilherme. Do you believe that the common bean could replace 100% of the regular peas like green beans?
Yeah, I don't think so. You see, there's one thing. The word replace, it's not what we should be looking for. You see, I always think one thing complements the other. So I don't think it will replace. I don't think it needs to replace. I think it brings up the opportunity of having another one. And they can all be on the market, and that's pretty good.
There's a question here about the formulation of meat analogs using these protein concentrates. And obviously, there are going to be other components involved in formulating plant-based meat beyond just the protein powder itself. Do you think side streams might be able to be incorporated back in as ingredients in these formulations?
Yes, they are already, right? We do have products on the market that they already being incorporated. And that's very funny because that's very, very funny because then think with me. Okay, so I do have a product that has pea protein, pea starch, and pea fiber. So the first question that comes to our mind, why didn't you just incorporate the pea grain? Well, I'm sorry, but if you incorporate the pea grain just as it is, it will not give you the technological properties for the product development, right? So that's the reason why we kind of separated everything, and then afterwards we add everything up together, but in different proportions, right? And each ingredient affording different properties for the product development. It's kind of funny, huh? But that's how it goes.
Yeah, absolutely. I think what you were saying earlier about breeding innovations might play into this. Perhaps there's a way to breed your raw material such that the right ratios of starches, dietary fibers, and proteins and lipids are already there from the beginning, so that you save these, processing steps.
Yeah,
But
that would be great, huh? Hope there are some breeding scientists on our audience.
All right. Just a couple last questions here. Do you have any other kinds of plant protein sources that you're looking at that you think maybe those in the audience should do further research on for plant-based meat? Also, if you have any literature recommendations, they're very open to it too, but I suspect this is a question that's best taken offline.
Yeah, well, besides the pulses, I would really say our first good options are the pulses, and that's why we decided to study them. We do have enormous um, many different sources that we can study. So like mushrooms is something that we really can take good advantage of them, right? The algae are also incredible. Um, Side streams from other productive systems from the production of other ingredients that not proteins. So maybe you might have protein-rich side streams from other kinds of processes. That's also a good opportunity. Oh, that's it.
Thank you.
Yeah.
All right. Well, that just about wraps up our questions for today. Thank you so much for a fantastic seminar. There were lots of comments throughout this chat that echoed my sentiments around you being a phenomenal communicator, and just saying that this is a really brilliant seminar. So thank you for this session. Thank you for sharing your wisdom and your insight with our community. Before we wrap up today, are there any last thoughts you'd like to leave our community of alternative protein scientists with today?
Well, I thank you. First of all, I thank you and Renee and GFI very much for the opportunity of sharing a little bit of what we have been doing with the community. So thank you. It's a great, great pleasure and I'm honored to be here. Thank you. And well, we do have many things to do. So let's keep it up, right? One step by one step, and we will all get there, helping each other and building a better way of life in many different terms, including food, right? And feeding. So that's it. Thank you.
Thank you
And
so
thank you,
much.
everyone.
What a
to
beautiful
be here.
sentiment to leave our community off with. Absolutely echo all of that. All right, thank you so much, Dr. Caroline Mellinger. Thank you, Renee, for organizing this fantastic seminar. And thank you all for joining us today. Feel free to check out gfi.org/community if you haven't yet joined our community of alternative protein scientists. And we will see you all again next month. Thank you so much, everyone. Bye.